Several electrical bulbs designed to be used on 220-volt electrical supply line are rated 10 watt. How many lamps can be connected in parallel with each other across two wires of 220-volt line if the maximum allowed current is 5 ampere? So this is similar to the one which we have done before. So, giving you guys a clue. You just have to find the resistance using the power information, and rest of it is similar to what we just did few problems back. So first thing is to note down what is given. So voltage is 220 volt, power is 10 watt, then current is 5 amp. You have to find how many of them are connected in parallel. So we are looking at a connection that is in parallel. So we don't know the resistance, but one thing is all of them have the same resistance. So the voltage and everything we know. This is what we're looking at. Again, the diagram is optional. You need not write it. The first thing first, we will figure out we don't know we know the current. We'll figure out what? We need to figure out the effective resistance. That's the first clue. Okay, if you find the individual resistance and the effective resistance, relate them and you're done. Let's figure out the effective resistance first. So we'll begin with let me write it a bit neat actually, not happy. Okay, so first statement is V is equal to I into R. That's as per your Ohm's law. So we have V that is 220, I is 5, and R is R effective, right? So in place of this, if I have a single resistance, what is that resistance? So dividing with 5, R effective is equal to 220 by 5 ohm. Okay, so we have the effective resistance. Now find the individual resistance and relate them. That's all. So the individual resistance, we can figure it out with the help of power. So we can use P is equal to V into I. But we don't know the current through the resistance. So we'll substitute for I. So I is equal to V by R. So this is V square by R. So power is 10. Voltage is 220. My resistance is R. So 1's are 1. 0 and 0 get cancelled. So R, the resistance of a single resistor is 22 into 220. Again, don't calculate. That this value doesn't matter. Now finding the effective resistance, number of resistance. So 1 by R effective is equal to, since we have all of them in parallel, we have this formula. So this is 5 by 220, which is equal to N by 22 into 220, where N is number of bulbs. So 220 get cancelled. N is equal to 110. That is your answer. Does it make sense? Right? All we had did was find the effective resistance, find the individual resistance of the bulb, relate them with the help of parallel formula, and we'll get the number of bulbs that we can connect so that we can draw a current of 5 ampere.